Basic principles of computer memory organization can be stated as follows. Well, first of all, that the memory is made up of multiple locations. Each location should be uniquely identifiable by its address. Each location has ability to store a value, and we're talking about uniform bit sequences. Unique identifier of memory location is referred to as an address, and the number of bits stored in each location is characterized as addressability. So basically, how many bits can be stored at each location corresponds to this new term, addressability. The address space provides us the range of unique memory locations. If address size is n bits, it has a potential to identify 2 raised to nth power unique memory locations. Number of bits stored at each memory location is characterized as addressability. Most memories are byte addressable, and right here we can demonstrate that we have a 1 byte of information that could be stored. All of these signals that were supplied by the data lines could be stored in a specific location here or here or here. Okay, each one of them would correspond to a specific address specified by the address line. So once again, the data that comes out on this end right here and supplied to each one of these memory RAM chips would be stored somewhere at the location which is specified by the address lines. Right? So if these combination of these address lines direct us to store it somewhere here, so that's where the information would be stored, written as individual byte. So right here, of course, you see that the number of wires over here is exactly the same as the number of the actual RAM chips constructing this entire memory. And these are the address lines telling these where this information should be stored or retrieved corresponding to specific location specified by the address lines. This is a demonstration of a 2 by 3 bit memory, which means that we have 4 unique addresses in this memory, and this memory is a 3-bit data type memory. So we have 3 data inputs that we can supply to store in this memory. So you should also recognize that right here, this is the each bit, each closed box represents 1 bit of storage for our respectable bits in the input, and each one of them is made up of a gated D latch. Of course, as we discuss the needs, the D latch, we have the write enable signal, which allows us to, based on the combination, based on the address signal combined with the address signal, this can switch on and allow us to store this data type somewhere in memory where this address is directing write enable signal to be activated. So for instance, if write enable combined with specific signal passing through this decoder specifies this memory location and write enable is on, then this data will be stored right here in this memory location made up of these 3 cells. When write enable is off, then of course each memory, we can then specify the address, again pass it through the decoder, and this time when the write enable is off, we will be able to again activate a specific location and be able to read this information to these outputs right here, going through these OR gates and collect the result. So basically this is reading the information, and writing the information happens from this side at the time when the write-enabled signal is set. So the next series of slides just elaborates a sequence of steps at which the access to this memory is being processed by the combination of address signals. So this is an example of reading a memory right here. So once again, we have the two address lines are set to 1. Both are set to 1. So this indicates by this highlighted sequence of wires. And then write enabled is off. So what happens is that right here we activate an AND gate, which is synced with this specific set of memory locations. And as a result, if we attempt to read the information, we'll be reading this information directly from these storages right here, from this storage, from this storage, and from this storage. So these 3 bits will be supplied on the way out, and we can read this information. So in this demonstration, we indicate that the address is set to 11, which apparently corresponds to this memory location made up of these 3 bits, and write enabled is 0, which allows us to do the reading, to accept this information from memory. And writing memory happens when the write enabled signal is set. The address is also presented to the decoder, and the correct word line is asserted. We say that the write enable asserts a specific line, and in that case, the other side of this circuitry, the data inputs will be accepted by those gated D latches, which would correspond to the specific write enable and address combination of the decoder signal.